Hello, this is David Birch at StarPath School of Navigation in Seattle with a quick note on star magnitudes. So that would be star and planet magnitudes. It's the number that specifies the brightness of the star. And I look forward to coming back and doing some videos on stargazing in general for navigation and navigators. But for now, we're just concentrating on this one concept of the magnitude of the star. And then maybe first just this quick picture of this star map, which shows these kind of stars here are magnitude 2 stars, and I'm going to define all of that. This kind of star, you see, I think, let's see how he does that. Is this that? Oh yeah. This, okay, so you see down here they have magnitude 2 and magnitude, first magnitude 1 stars. And so these are magnitude 2. This is a Big Dipper. And most of the stars, these 2 and these 3 here, these are magnitude 2 stars. And then these with a little dot in it, that's a magnitude 1 star. That's the bright ones. And here's Arcturus and Vega, Deneb, Spica, Regulus, Altair. That's pretty much. There's only 20 of those, by the way, in that category. And we'll come back to that. And let me just show you where you can get this map. It's a free download from the... originally, it's from the United States Naval Observatory. But we have a link to it here, starpath.com/cellnav book. I'll put that link in the video, and then you just click this link here and you get it. Also, if you've not been to this page, this is a support page for our textbook, and even if you're not using our book, you may find other things here that are useful for you. Okay, so then let me see what I want to do next. Oh, actually, let me show you something else related to the stars that if you don't know about it, it's really very valuable to have. It's a program, it's a free program, really fantastic program called Stellarium. And I'll put that link in there too. I think it's just stellarium.org. There's a PC version and a Mac version. There's a little bit of a learning curve to it. There's some commands over here when you go that way and some commands down here, but it's extremely versatile. It'll do tons of things, various perspectives, and so on. And when we do general talks on stargazing later on, this is the program we use. But you see here, and then this is the Big Dipper here, and when you click one of these stars, it tells you all about it. You see that happens. Well, that's a coincidence. That's the Doobie, magnitude 2.0. You go this guy 2.3. 1.75, which sort of rounds to 2, Alcade out here, 1.85, so forth. Then you get to the bright guys, Capella, 0, almost 0. Deneb, what's that? 1.25. So those are the magnitude. That's what we want to explain. And here, okay, and so these... Okay, let me go back over how this came about. The system dates, it's a logarithmic system. It dates back to about 150 AD, maybe even earlier, to Ptolemy and other scientists of those days in Greece. Greece, they were in Egypt, northern Egypt, Alexandria. And so he decided that the brightest star that we can see is 100 times brighter than the faintest star we can see. So he decided that from the very faintest here to the very brightest, it's going to differ by a magnitude by 100, factor of 100. And then he decided that there should be 5, we'll divide this up into 5 magnitudes. Now what that leaves us with is that each magnitude then is a factor of 2.5, which is the 5th root of 100. And I'm going to show you an article in a moment that lays some of these things out. So there's not then, because it's a logarithmic scale, there is not an easy way to compare brightness and magnitude number. And so we have a table, and that's one of the main things I wanted to show you. Let me come back up here. This is an article which we just posted. It will be added to the next printing of one of our books. Here is this table. So this is how you compare two magnitudes. So you have two stars that differ by a magnitude of 1. They have a factor of brightness, 2.5 difference in perceived brightness. But if they differ in like 3.2, that's a factor of 19. And then later in this article, there's some examples. For example, there is Arcturus with a 0.2 magnitude, Dubhe with a 2. That has a difference in magnitudes of 1.8. Then you go back, that table reference is wrong. That's this table here. And, okay, what are we after? 1.8, 1.8. 1.8. So 1.8 is a difference of 5.2. So the star Dubhe is, or Arcturus rather, is 5.2 times brighter than Dubhe. So that's the way you use that table, and that's what this table is for. And the other thing I wanted to show in this article is where do you find the brightness, the magnitudes of the bodies that we use, and the planets are easy. They're on the daily pages. Every page of the almanac they have them right up here, like Venus. The other thing about the system, it makes it a little more complicated. So they're a logarithmic system. Each of magnitude differs by a factor of 2.5, and then the lower the number, the brighter the star. And then with that scale, the planets then become so bright that they are actually a negative number. So you see this planet Venus here, minus 3.4. So that would, if you compared minus, and then you'd have some other examples. You worked in some numerical examples here. For example, Venus can be as bright as minus 4.3. Polaris, the North Star, is 2.1. That's a difference. When you take away minus 4 up to plus 2, that's a difference of 6.4. And then you go back into the table and you see that Venus, when it's that bright, is 400 times brighter, perceived brightness, than Polaris. So that's how you use that table. So the planet brightnesses are shown here. There's only 2 stars that are bright enough. They're southern hemisphere stars. There's only 2 stars bright enough to be negative. One is Sirius at minus 1.5, and Canopus, I think that's about minus 0.7, something like that. Now, then the stars, you find the brightness of the stars. They're in the back of the book. There's a list of stars in the back of the book. And that's where these magnitudes are listed. And there's a card, depending on what kind of almanac you buy, there's a cardboard card stuck in as kind of like a bookmarker, and that has an index to the stars in it, and that has the magnitude listed if that card is really there. And then, but they're in the back of the book as well. Let's see here what else I might want to say about this. Okay. So then here is the point, and then we come back maybe to this picture. So it's a complicated system, but I want to just assure all navigators that from a practical point of view, the star ID, understanding the brightness and the magnitudes of stars, is very valuable for star ID in general. And it's a complicated system. However, we don't have to worry at all about the technicalities of that. We can just consider 3 magnitudes of stars. There are the bright ones. And so there's here we have, in this one, Vega, then again, only 20. In the north and south sky, all together in that category, there's only 20 stars. There's only 20 of those. And then just find one anyone, your favorite one, and then that's a reference, and you'll know when you see stars like that, that is the bright ones. And those all as a group are called roughly magnitude 1. Now, their actual magnitude could vary anything from 0 to 1.3 or 2 or 4, something like that. But generally, it's about 1. Those are the bright stars. Then the second category that you could just call loosely magnitude 2 stars, and that's like those in the Big Dipper. Like those in the Big Dipper, these stars here. Now, the thing that may be strange when you look at, these actually look brighter than most Big Dipper stars. It's even exaggerated a little bit in this program, right? But when you look at the sky out there, keep in mind there's only about 70, north and south sky altogether, there's only about 70 of those that are magnitude 2 stars. And those are called magnitude 2. Now, when you're doing celestial navigation, you almost always use only magnitude 1. It's very, periodically you fill in a triangle with magnitude 2, but mostly it's all magnitude 1. Not only is it magnitude 1, you could probably use the same 3 stars, maybe 3 stars or 2 stars in a planet combination, the same 3 or 4 bodies going clear across the ocean. Clear across the ocean, Pacific or Atlantic. You would use the same ones every night, maybe a different set of 3 in the morning. Then the next group is just roughly called magnitude 3 stars, and that's like the stars in the, a little bit hard to see it here. Let me see if I can cheat. Yeah, this is the Little Dipper. See, here's the Big Dipper. Big Dipper is always pouring water into the Little Dipper. That's a pretty nice thing to know. And this is Polaris, a North Star, and that's Kokab. And these stars in here, in the handle here, are magnet. See, that's almost a 2. This is a 2, Kokab and Polaris, I think. Well, let's click it. What is it? 1.95. Polaris is a magnitude 2. Kokab, what's he? 2.05. So there's 2 magnitude 2 stars. But the neck, the handle of the Little Dipper, well, that's a 4. It's not right. That's a 4. That's a 4. Oh, I've got to get... That's a 3. That's the other one of the guards. Well, I better come up with a better example. What do we have here in magnitude 3? Oh, no, those are better. Anyway, with a program like this, you can find the magnitude 3 stars. It's going to be, you probably never ever do a sight of a magnitude 3 star, but I should clarify some example that's a little bit better. These 2 stars together are called the guards, and so the other guard beside Kokab is a magnitude 3 star. So that's all that we need to know. Magnitude 1, bright ones, magnitude 2 like the Big Dipper, and then magnitude 3 like the next group down. And so let me see. So it's actually then, even though it's a complicated system, that's the only kind of category we know. And then this article is here that gives you some practice with comparing brightnesses. And I think I'll stop there and later come back with some more on stars for navigators. This is just on the brightness factor, and then I'll give a link to this article and the other things I've mentioned.